This is part 3 of our multi-part series on chemical conflicts. If you haven't heard the last 2 episodes, go back and listen to them because, at least in my mind, I know there's a lot of overlap, but they do kind of build on one another. In the first episode, we talked about chlorine conflicts, the risks of mixing chlorine with other products directly together. In the last episode, 122, we talked about what conflicts once it's in the water. Specifically, we talked about algicides and polymers. Those will conflict with chlorine, and polymers will conflict with enzyme as well. In this episode, we're going to talk about alternative sanitizers, chlorine alternatives, basically. Joining me again, Terry Arko, the chemistry expert and the guru. Thank you for being with us, Terry.
Sure. Glad to be here again, Eric.
Yes, thank you for being here on short notice. You don't really know what's coming your way, but you have this all in your brain, so we're going to pick your brain. This is episode 123. Anything you want to add before we get into it?
Let's just go. I'm ready.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, Terry, let's start with biguanides. I know they're not that popular, but every so often we get some questions about it. I know they exist. What is a biguanide and how does it work?
That again is a polymer, polybiguanides. And polybiguanide actually is a form of a disinfectant that came out of the medical world. It's actually a surgical scrub that's used to disinfect bacteria and germs. That's where it came from.
Interesting.
Somebody somehow got hold of it to use it as a alternative to chlorine in swimming pools in the form of biguanide. And it is a good bacteria killer and disinfectant, but not a real strong oxidizer like chlorine. So that is an issue and probably one of the biggest problems with biguanide that you have. And if you're on a biguanide system, you're going to use a hydrogen peroxide form of a shock and an oxidizer on a pretty regular basis. And the one thing about that hydrogen peroxide is that I believe it's about a 33% hydrogen peroxide.
Wow. So way different than the hydrogen peroxide I have in my medicine cabinet, which I believe is 3%.
Right. And so 3%. And if you ever put hydrogen peroxide on a cut, or if you've splashed it in your eye or something like that, you know it's
no joke.
Yeah, it is irritable. Well, if you kick that up, to 33%, you can imagine if you splashed some of that in your eye or got that on your skin, it would not be a pleasant situation. So that's one thing.
That would be a wicked oxidizer. Can you use a non-chlorine shock like potassium monopersulfate in a biguanide pool?
No, see, that's the issue and the challenge with biguanide systems if you get locked into using biguanides in your pool is that almost any other type of pool chemical is not compatible with it. For example, as you brought up, if you wanted to use, say, a non-chlorine shock like potassium monopersulfate, that's incompatible with biguanides. And if you were to do that, what's going to happen is it's going to turn your pool water orange, and you're going to get this orange gelatinous gel on the bottom of your pool, which is very hard to remove.
Whoa.
So it's not compatible with any type of algicide, not compatible with chlorine.
Terry, you just gave me a great idea for me to ruin my pool with.
Yeah, it'll do it. It'll do it.
Wow. Okay, so that ties into the next one, hydrogen peroxide. Hydrogen peroxide, I know, in the medical field and in the industrial applications is used to actually dechlorinate wastewater.
Exactly right.
So it conflicts directly with chlorine. It will neutralize it out. Now, interestingly enough, you can use hydrogen peroxide cleaning products in the bathrooms and the locker rooms of a commercial facility. It could be used as a deck cleaner, but we would recommend against that because it could get into the skimmers or the gutters. And I'm speaking to the commercial customers here. It's not necessarily a bad thing to clean the floors of your bathroom with it, as opposed to like a dimethyl ammonium chloride where the swimmer could track that into the pool, or they're going to be dripping wet from the pool and go into the bathroom and create chloramines when the ammonia interacts with chlorinated water. It doesn't really go the other way. It may neutralize it, but it's not really going to be a conflict out of the water with hydrogen peroxide. That said, do not think just because hydrogen peroxide is a great oxidizer that it can go into chlorinated water at all. It should not be used in a chlorinated pool.
Yeah, I had a situation where for some reason or another, someone thought that hydrogen peroxide was the liquid version of potassium monoocre They felt like, well, hey, I can't get the MPS, so I'm going to go get some hydrogen peroxide
Ooh,
and I'm going to use that in place. And they shocked their pool with it. Well, their chlorine immediately went to zero.
right.
That's when they called me on the phone and they're like, I don't know what's going on. And it took almost 2 weeks before they got to the point where they could get a chlorine residual back in that pool from the amount of hydrogen peroxide they'd put into the pool.
You hate to see it. It's kind of funny now, but it probably was not so funny at the time.
No. So that's a huge mistake.
Now, we talked in previous episodes about bromine. In the last episode, we talked about sodium bromide being a conflict because chlorine will have an affinity for oxidizing the bromide ion back into hypobromous acid. And in the bromine episode, we talked about the bromine cycle. In that episode, we talked about the need for an oxidizer to recharge the bromide ion into hypobromous acid. So that begs the question, if you had a bromine pool, could you use hydrogen peroxide to oxidize that into hypobromous acid?
Yeah, you could. The problem is that with certain forms of oxidation, you can form bromates from bromine. And so you have to be really careful about that, particularly if you have ozone, UV, something like that with bromine. And overall, EPA is already beginning to create regulations where they're not allowing bromine and UV or ozone to be used in pools.
As a refresher, bromates are the known carcinogen that are a byproduct.
Right. They're neurotoxins and carcinogenic. Yeah.
Right. So you don't want them in the pool. So this is why we don't use bromine in outdoor pools because of direct sunlight.
Correct.
And you don't use them on pools with secondary systems, UV or ozone. In general, it's really primarily used in hot tubs only right now, but try not to put it in a big pool. Okay, so those are alternative sanitizers. We have biguanides, which is reinforced with hydrogen peroxide, and then we have bromine. So now let's talk about those secondary systems. The secondary systems that we primarily find on pools are UV, whether low pressure or medium pressure, ozone, and there's multiple ways to create ozone, AOP, which is advanced oxidation process, which creates hydroxyl radicals, and then a few other technologies that exist to sort of supplement things, even though they don't create a residual and they may not get EPA registration for kill claims, they can enhance the water. Something like hyperdissolved oxygen is a good example of this. If the technology proves out, we've heard some positive reports of hydrodynamic cavitation is one of these things. It remains to be seen. I personally have experienced hyperdissolved oxygen. I have not experienced hydrodynamic cavitation, but I'm sure there will be more technologies to come out. Generally speaking, Terry, why are none of these secondary systems primary systems?
Because none of those systems can leave a measurable residual in the pool water.
What does that mean?
Well, that means basically you have no sanitizer or protection out in the vessel of the pool. They're primarily reliant upon contact. And with UV, it's basically contact with the light rays that it's putting out into the chambers. Ozone, same thing. I mean, ozone basically is being produced in a certain area of the pool through the plumbing and the piping. It's being venturied in, but by the time that reaches the pool, that ozone is already degraded considerably and doesn't last long out in the vessel at all. It doesn't leave a measurable residual like you get from chlorine.
Right. I know AOP, ozone, just kind of the rule of thumb, it's 6 to 8 feet of plumbing usually.
Right.
But in that 6 to 8 feet, they kill just about anything.
Correct.
They're incredibly powerful at what they do.
That's absolutely correct. But again, if you don't have that protection out in the pool, so an example I can give you is with crypto. So ozone will deal with crypto. We know crypto's chlorine resistant, right? So it can take 10 days at 1 ppm of chlorine to inactivate crypto in a pool. Ozone will inactivate crypto like instantaneously. If it passes in that active ozone, it's pretty much gone within seconds.
If it passes through that plumbing.
If it passes and has that. So as an example, when we had a lot of the crypto outbreaks going on, there was a YMCA that's what they did. They put in ozone systems and they thought, we're good. Well, 2 weeks after installing these ozone systems, they had a crypto outbreak. Why? Well, because the crypto was out in the pool and it never got exposed to the ozone, and somebody swallowed it before it got exposed to the ozone, and you had a problem. Ouch. So that's where residual chlorine could have helped, possibly in that case, although we know it's chlorine resistant, but it still could have helped.
So it brings it back to that holy trinity of pool care where you have circulation, filtration, and chemistry. Mm-hmm. You need all three. You can't operate with just two of them. And so you could have the best secondary system, and you could even have a chlorine residual. But if you don't have circulation to bring the water to that ozone system, it doesn't really matter. And if you don't have a filter to take the hard particles out, it doesn't really matter. Things can overwhelm each other. And so you always want to remember that triangle of circulation, filtration, and chemistry. Not necessarily in that order. In some ways, you could say that they're equally important, but it's immaterial. They're all three codependent on each other.
They're all important. They're all important.
They are. Are there any other alternative sanitizers that you can think of that you would like to bring up? Those are the only ones I wrote down in the show notes that Jared will never read.
Yeah, I think that mostly covers it. Of course, there's new things popping up all the time, we know.
Well, Terry, I appreciate you being on this. This has been episode 123. We're talking about chemical conflicts. This one was about alternative sanitizers. To recap, we talked about biguanides and the supplemental shock of hydrogen peroxide, neither of which are compatible with chlorine at all. Then bromine, which we've talked about in a previous episode, and secondary systems, which are not primary systems because they do not create a residual. Do you think we missed anything?
Not at this point. Possibly we could have. I'm sure something will come up, but...
Yeah, well, we're not perfect. You know what? We're going to publish it anyway.
I think we covered the mainstays.
Okay, cool. If you have any questions about this, whether it's for your pool or a customer's pool, if you're a pool pro, reach out. Our help center is ask.orendatech.com. You can email us at podcast@orendatech.com. Thank you so much for all of you who listen. We continue to get great ideas, although Terry has come in here and given me 2 really good ideas for episodes, so I may have to interject those in front of some of the other ideas. But we have 1 more episode to go in this series, maybe 2. Not really sure. I'm Eric Knight, and this is Terry. We're from Hassa and Orenda, and thank you so much for listening to the Rule Your Pool podcast. We will see you next week. Thanks, Terry.
Thank you.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.